All right. So yesterday, we began looking at velocity and acceleration. We saw that velocity is equal to the change in position or distance over time. We saw that acceleration is going to be equal to the change in velocity over time. We can expand this out, make it your final position minus your initial position over time. So this simplifies down to your velocity is equal to xf minus xi divided by t. Solving for xf, where's my green pen? So solving, we first multiply t to both sides. Times t divided by t cancels out, leaving us with, I'm going to switch this around, vt is equal to xf minus xi, just some basic algebra. Then I'm going to add to both sides xi minus xi plus xi cancels out, leaving us with v times t plus xi is equal to xf. I'm now going to flip this around so that we have xf is equal to xi plus v times t. That gives us, so this is the exact same thing as this. All I did was just do some algebra on it. Let's do the same thing over here. So this is equal to vf minus vi divided by t. Doing the same process. So a is equal to vf minus vi divided by t. Multiply both sides by t. These t's will cancel out, giving you a times t is equal to vf minus vi. Now add vi to both sides. Minus vi plus vi is 0, so that cancels out, giving us vi plus a times t on this side is equal to vf. So swapping this around, we get vf is equal to vi plus a times t. Does that make sense? All I did was just swap around some variables. Note that for this version of the equation, this assumes no acceleration. Ra is equal to 0 meters per second squared. I'm trying to load up my equations to make sure I match them. Have you ever heard of calculus? Physics is inherently connected to calculus. Calculus isn't taught on the high school level, it's taught on the college level. So in order for me to show you how these equations come about, you would have to know calculus. For the most part, I'm just going to tell you that this is the equation and you're just going to have to believe me. You know who Isaac Newton is? Do you know some of the things do you know what he invented?
No, I mean, I just don't know.
So he invented calculus. He invented calculus to work on physics. So that gives you an idea. He's working on physics, he's coming up with the 3 laws of motion, and he realized math is not good, algebra is not good enough. You cannot invent new physics with the current algebra now. So he goes and invents all of calculus in order just to work on physics. Of course, we're not going to be doing that. So, let's see. So, if there is acceleration, is not 0, this equation will expand into xf. Let me make sure I can see what I'm writing. Xf is equal to xi plus vi times t plus 1/2 at squared. These are being multiplied together. So this is another equation. So this is generally our first kinematic. Equation. And this is our second kinematic equation. You can see that if A is 0, if you were to plug A equals 0, this term disappears. So if I plug in A equals 0, and we're left with this. This portion is just that.
Excuse me, teachers and students, the Bell system is back on track and working correct, so when you hear the bells, it will be time to change classes again.
Now then, I can subtract xi from both sides of the equation. On the left hand side, I'm going to get this up so you can see. So I can subtract xi from both sides, and I'm left with xf minus xi is equal to vit. Note that if I put two variables next to each other, it means they're multiplied. Plus 1/2 at squared. So xf minus xi is the same thing as delta x. So I can replace this term with delta x, or the change in x, is equal to vit plus 1/2 at squared. So this is another form of the equation. It's simplified down. It's a lot shorter than writing the full version of the equation, but these two are the second kinematic equation. This is the first. So this tells you, this equation tells you how your velocity is going to change with time. This equation tells you how your position or distance changes with time. Note that I will also say, so delta x is change in position delta x is also distance traveled. So I will call delta x your distance. It's also your change in position. That's how much you change by. These are going to be your first two kinematic equations. They're going to be your primary ones. There's also two more. I will go ahead and tell you the other two, but we're primarily going to be working with the first two for now. So we have kinematic equations. Our first one is going to be VF is equal VI plus A times T. For the second one, it's going to be delta x, change in x, is equal to VI times T plus 1/2 AT squared. Our third equation is going to be delta x is equal to VI plus VF divided by 2. So the average, so your average velocity times T. And then the fourth one is going to be final velocity squared is equal to initial velocity squared plus 2 times A times delta x. These are going to be the four main equations. Number three number three basically says that you can take your average velocity, whatever your velocity average was, and basically use that to figure out your total distance. Number four is very complicated. There's no way I could possibly explain how it's derived without calculus. Number two, I can't explain how you get this 1/2 AT squared without calculus. That requires calculus to do, but these are going to be your equations. So let's do a problem. So the acceleration due to gravity is roughly 9.8 meters per second squared. So every second, so if you were to jump off of a building, every second your velocity is going to change by 9.8 meters per second. So after 1 second, you're going about 10 meters per second. After 2 seconds, you add another 9.8, or roughly 10, you're going 20 meters per second. You will keep doing this. If you're in a vacuum, you will keep doing that and getting faster and faster and faster. There's also going to be air resistance that'll slow you down, but for this class, we'll ignore air resistance. So here's a question. How far would you travel after 10 seconds of free fall? So if your acceleration is 9.8, so if you go jump out of a plane, what distance would you travel if your only acceleration was 9.8 meters per second?
9 meters.
No. So let's look at it. So we're trying to find, let's look at our given. So our given values is 1, we're looking for our distance. We're looking for distance. We're given that the acceleration is 9.8 meters per second squared. Let's assume that our initial velocity is 0 meters per second. We're told the time is 10 seconds. So we have a t, a vi, and an a. If you look at this equation here, we have a t, we have an a, we have the t, and we have a vi. So we will use the second equation. Delta x is equal to vi times t plus 1/2 at squared. So that would be 0 meters per second times 10 seconds plus 1/2 times 9.8 meters per second squared times 10 seconds squared. You'll probably need a calculator for this class. You remember which one was yours? Yeah. So 0 times 10 is 0. 1/2 times 9.8 times 10 squared. So that would be 1/2 times 9.8 meters per second squared. 10 squared is 100 seconds squared. So 10 seconds times 10 seconds is 100 seconds squared. The second squares will cancel each other out, leaving us with just meters. So that's 490 meters. So if you were to jump out of an airplane, you'd go almost 1/2 kilometer in 10 seconds. Let's reword it. How far would you go in 20 seconds? All right, let's reword it. How far would you go in the next 10 seconds? So Let's see. Let me do something else first. How fast would you be traveling? How fast would you be traveling after 10 seconds? So our time is 10 seconds. Or initial velocity, again, we'll assume is 0. Or acceleration is 9.8 meters per second squared. And we are looking for final velocity. So we got T, VI, and A. We're looking for VF. So we will use this first equation. Final velocity is equal to initial velocity plus AT. So our initial velocity is 0 meters per second plus 9.8 meters per second squared times 10 seconds. So we would be moving at 98 meters per second. So after 10 seconds, you will travel a distance of 490 meters, and you will be moving at 98 meters per second. So almost 100 of these, so take 100 of these, laying them out, that's how fast you'll be moving every second. 100 meter sticks every second about. That's very fast. Now, how fast would you be traveling in next 10 seconds? So our initial velocity, we're going to use our previous value. So we're looking at the next 10 seconds. So we take our old 98, that's what we're starting with. Our time, we're going for a period of 10 seconds. So time refers to a time interval. We're looking at our interval of 10 seconds. So we're still 10 seconds. Our acceleration doesn't change. And we use the same equation. VF is equal to VI plus A times T. Plugging that in, we get 98 meters per second plus 9.8 meters per second squared times 10 seconds. And you see that you would be moving now at 196 meters per second, almost 200. How far would you travel in the second 10-second interval? So after the first 10 seconds, your speed, your initial speed is now 98 meters per second. And we're looking at a time interval still of 10 seconds. And our acceleration is 9.8 meters per second squared. We use the second equation. Delta x is equal to VI t plus 1/2 AT squared. Plugging that in, we get 98 meters per second times 10 seconds plus 1/2 9.8 meters per second squared times 10 seconds squared. this, so seconds will cancel out, leaving us with just meters. So that would be 980 meters plus 490 meters. These two will add together to be 1,470 meters. That is the total distance you would travel in the second interval. If you want to figure out your total distance, so this is 10 seconds, so you travel for 20 seconds. You can add this number and your previous number together, and I'll tell you how much distance you would travel in 20 seconds. So, yeah, 1960. So almost 2,000 meters for traveling in 20 seconds free fall. Again, we're ignoring air resistance. Technically, you're going to reach a max velocity because air is pushing you up. Think of parachute. If you deploy a parachute, you increase your air resistance, and you'll just glide down for a few minutes. If you did it on the moon, for example, one, there's a different gravity, but there's no air on the moon. So you would actually, if you're in outer space, if something were to happen and one of the astronauts who, like on the Apollo missions, if their orbiter were to mess up and they started free falling down to the moon, they would strike the surface of the moon at really, really high speeds. They would almost reach bullet speed before they hit the moon. Because there's no air resistance to slow you down. Is this all making sense so far? So let's do some more examples. A car at rest travels 100 meters in 5 seconds. What is the car's acceleration? So again, how you do these physics problems is you're going to take the words and identify the variables. So a car at rest, what does that tell you? It's not moving. Which variable does that correspond to? Initial velocity. So your initial speed or initial velocity is 0 meters per second because this is the start of the problem. So this is your VI. Travels 100 meters. Which variable will that correspond to? VF is velocity. 100 meters is a distance. So this will be your delta X. So it changed its position by 100 meters. 5 seconds. Which variable does that correspond to? Time, or T. So T is equal to 5 seconds. And is asking you what is the car's acceleration. As your A. So we're looking for A. Anytime you're given a word problem, you're going to need to extract the variables from it. Now we look back at our list of equations. We are trying to find acceleration, and we are given VI, delta X, and T. Do we know anything about VF? No. So this has a VF in it, we would not use it. This has a VF in it, we do not use it. This has a VF in it, we do not use it. That gives us one equation exactly. This second equation is the only one that doesn't have VF in it. So we use the second equation. Delta x is equal to VI times T plus 1/2 AT squared. We're trying to solve for acceleration. Guess what we have to do? Algebra. So we are trying to solve for A. In order to get A by itself, we need to look at other terms. So we need to get rid of this term because it's on the same side as A first. So we would subtract VI T from both sides. VI times T minus VI times T cancels out, giving us delta X minus VI T, and that would be equal to 1/2 AT squared. Again, we're trying to find A. So there's no more terms on this side of the equation. So we're going to multiply both sides by the inverse of 1/2. Or you can divide. I'll just do that. There's two ways you can do this. You can either multiply by the inverse of 1/2 or divide by whatever is being multiplied. So A is being multiplied by 1/2 and T squared. So I'm going to divide both sides by 1/2 AT squared. Not AT squared. I'm going to divide both sides by 1/2 and T squared. So divide this side by 1/2 and T squared. 1/2 divided by 1/2 cancels each other out. T squared and T squared cancel each other out. So I am left with delta X minus VI times T divided by 1/2 T squared. And on this side, I'm given A. Now I can plug these numbers in. A is equal to delta X. Delta X is 100 meters. Minus 0 meters per second times time is 5 seconds. Divided by 1/2 times T squared, so 5 seconds squared. 0 times 5 cancels each other out. So I'm left with 100 meters on top divided by 1/2 times 5 seconds squared is 25 seconds squared. Then you can plug that into the calculator. Note, very important, if you're plugging this in a calculator, you need to put the entire denominator in parentheses. If you plug that into the calculator, you will get an answer of 8. And it's meters divided by second squared. This is also an acceleration, so I'd expect the units to be meters per second squared. Following? Because this is going to be the entire first semester almost. A lot of math. Are you comfortable with doing this algebra?
Yeah, I'm pretty good at it.
Alright, because this is going to be most of what the class involves. So basically, first step, identify the variables. Second step, identify which equation to use. You look at the variables you're given, what you're trying to solve for. Ensure that the equation contains all of them. So this contains delta x, vi, t, 1/2. You don't need 1/2, but a is what we're looking for, t squared. Once you identify the variable, or once you identify the equation, write it down and solve for what you're looking for. You're solving for a. Note that I prefer using pure algebra. If you wanted to, after you identified the equation, delta x equals vi times t plus 1/2 at squared. What you could have done to make things simpler is one, leave off units. I know that my final answer is going to be in meters per second squared. So take your delta x, plug in 100. This would be 0 times 5 plus 1/2 times a times 5 squared. So 0 times 5 cancels each other out. That'd be 100 equals 1/2 times a times 5 squared is 25. 100 equals half times 25 is 12.5 times a. 100 divided by, then you would divide both sides by 12.5. 12.5 cancels out, giving us 100 divided by 12.5 is 8. That's your A. Make sure you do not forget units. Units for acceleration would be meters per second squared. And that's another way you could have done it. I prefer pure algebra and then plugging in numbers at the end. Because if I give you another question exactly like this, if I said suppose the cars was already moving at 50 meters per second, I could have took this equation and instead of plugging in a 0, I could have plugged in 20 meters per second here. And that's all I had to do was come back and change the 0 to a 20, and it would spat out the answer. So let's do another example. So a car goes from 10 meters per second to 20 meters per second in 3 seconds. What is the car's acceleration? So again, first thing you need to do is identify variables. Look at all your numbers. A number there, a number there, and a number there, and we're looking for acceleration. So you go from 10 meters per second to 20 meters per second. These two are speeds. Meters per second is a unit of speed or velocity. This will be your initial velocity. This will be your final velocity. This will be your time, and we're looking for acceleration. So write it down. VI is equal to 10 meters per second. VF is equal to 20 meters per second. Our time is 3 seconds, and we are looking for acceleration. Which equation will we use to solve for acceleration? First one. So VI, VF, T. We got our 3 known variables, and we got 1 unknown. So that is correct. So you begin by writing it down. VF equals VI plus A times T. So we are solving for A. So we look at other terms. So there's our only other term. So we subtract it off, which gets rid of it on this side. So we get VF minus VI is equal to A times T. Again, we're solving for A. We have no more terms on the side, so we need to look at what variables are being multiplied. Divide it on both sides. So the only term being multiplied is T. So divide T on both sides. And we are left with A. So we're left, I'm flipping it around. I won't do that actually. So we're left with VF minus VI divided by T is equal to A. I usually skip a step. I usually don't write. I go ahead and already flip it. So A is equal to VF minus VI divided by T. You also could have known that you're looking for acceleration. This is the definition of acceleration. So now we can plug in variables. That's 20 meters per second minus 10 meters per second divided by 3 seconds. That would be 10 meters per second divided by 3 seconds. These seconds are going to pair up. And we're going to get an answer that is in meters per second squared. So meters per second divided by a second is meters per second squared. And we get an answer of 3.333, so on. All right, let's do one more. Suppose a car is going 10 meters per second, and after traveling 500 meters, its speed or velocity increases to 40 meters per second. What is its acceleration? So let's identify our variables. So look at our numbers. So suppose the car is going 10 meters per second. So this would be what variable? VI, initial velocity. This would be which variable? Delta X. And this would be VF. And we are looking for acceleration. So VI is equal to 10 meters per second. VF is equal to 40 meters per second. Delta X is equal to 500 meters. And we're looking for acceleration. So, which equation will we use? The fourth one, very good. So we have VF, VI, delta X, and we need to solve for A. So copy down our equation. And we're solving for acceleration. So VF squared minus VI squared equal to 2A times delta X. I moved this to this side of the equation. Moved it to that side. I'm still looking for A. So I need to get rid of the 2 and the delta x. So to move this over here, I would divide by 2 delta x to give you the acceleration. Plugging it in, so our VF is 40 meters per second squared minus 10 meters per second. And all that squared divided by 2 times 500 meters. So 40 squared meters per second squared is 1600 meters squared divided by second squared. So that squares that. So again, if you have a meter per second times a meter per second, the meters are going to double up to be meter squared. The seconds are going to double up to become second squared. Then that'll be minus 100 meters squared per second squared divided by 1,000 meters. This is going to combine to be 1,500 meters squared divided by second squared divided by 1,000 meters. This meter is going to cancel out with one of these meters, and you are given an answer of 1.5 meters per second squared. All right, we'll continue tomorrow.